Now we're going to look at variables that affect the size of your correlation coefficient. And this is where we have to revisit, or at least some of these things anyways, we're going to revisit the assumptions. Now, one of the assumptions was that x and y must both be normally distributed, right? And so what happens if x or y, or maybe both, are not normally distributed? What happens is you no longer have any chance of finding a perfect relationship. So it's impossible to find an R value that will equal -1 or 1 if one or both of your variables are not normally distributed. Now, what if x and y are both normally distributed? Does that mean you will find a perfect relationship? No, but at least you have a chance now, okay? Might need to replay that, so make sure you get it. Number 2, if the relationship is not linear, this will decrease your R value. All right, so one of the assumptions, remember, is that the relationship between x and y is a linear one. And we looked at a scatter plot where that's true. And we also looked at one where we saw a curvilinear relationship. If we have that curvilinear relationship and we don't know it, our R value could be very small, and we'll be tricked into thinking that the relationship is a bad one, is a weak one. But in reality, it's not. So I thought I had a diagram to show you this. Well, if let's say, we have a curvilinear relationship, and let's just pretend that all the points fall on the line. So imagine in your head right now, an upside down U. All right, so it's a curvilinear relationship, and all the dots fall on the line. It's not a straight line, though. Pearson, it can only calculate a straight line. Pearson can't do anything else. So when Pearson calculates that straight line, it's going to miss half the data points. You're going to get an R value very, very close to 0. And you would conclude, without looking, if you didn't look at your scatter plot, you would conclude that, I guess I have no relationship between x and y. But what if, in fact, it was a curvilinear relationship and all those points were on the line? If you saw that, you would come to a very different conclusion, right? You would say, oh my gosh, I actually have a really strong relationship. It's just not linear. So you should always, always get a scatter plot for every correlation you want to investigate. Get a scatter plot. You have got to make sure that the relationship between x and y is actually a linear one, because sometimes weird stuff happens, and you would want to know that. Right. Number 3, violating the assumption of homoscedasticity will typically decrease R. Now, I am not going to explain that. We'll look at this when we talk about regression. All right. I would like you to know it now, but you'll understand it later when we get to regression. Number 4, outliers. Remember, that was one of the assumptions. We said outliers, you should have no outliers in variable x and no outliers in variable y. Now, outliers can either increase the size of the R value or decrease the size of the R value, and it depends where the outlier is located. So that's illustrated here. So this is the outlier. If we were to ignore it, we would say, we've got a great pattern here, right? Now, isn't this an exception from the pattern? It's way far away from the pattern. It's going to take the line's going to have to kind of shift a little bit. It's not going to shift all the way to this red dot. This is only one red dot, but it is going to shift a little bit to take into consideration that there's an outlier here. All right. So if we were to include this outlier, our R value would decrease. sorry, did I say if we were to take it out? If we were to take out this outlier, if we were to take it out, we would get a very strong R value, very high R value. But if we leave it in, then we're going to see a decrease in the R value because it's going to be impacted by this data point that doesn't fit with the pattern. Okay, so sorry if I got that confused right there for a second. So if you omit it, your R will go up. If you include it, your R value will go down. Now, what about this one? You might think, oh, if we omit it, then our R value will increase, right? If we omit it, just like here, we said if we omit it, then the R value is going to increase. Well, the only reason why it will increase if we omit this one, is because this one is taking away from the pattern. But this one is reinforcing the pattern, right? It's reinforcing this direction. So if we include it, our R value will go up. The R value is reinforcing the pattern. The dot here is reinforcing the pattern. If we omit it, then the R value will go down. You might want to take notes on this, okay? So again, if the point is reinforcing, if the outlier is reinforcing the pattern, this increases R. If the outlier is taking away from the pattern, then the outlier will decrease R, okay?